Yeah,
There she is. How are you?
I'm good. How are you?
I'm living the dream
Perfect.
down here in sunny Florida.
Oh yeah, it must be hot there now.
Let's see, what do we got? I'll tell you in a second. File new. Clocking in at 80 degrees.
Wow. Nice.
But it's nice out there. It's cloudy a bit, but not as beautiful as yesterday. We're fairly spoiled.
Yeah, you are.
All
Okay.
right. So what do you want to focus on today?
So we went over second derivative inflection today, and
Oh,
I have a homework on that due tomorrow, and I thought maybe it would be helpful to go through that.
awesome. Do you want to send it to me, or how do you want to work it?
I can send it to you, but yeah, I can. I'll save the PDF now and send it to you.
Okay. Cool.
Do you want me to just email it?
Yeah, that's easiest.
Okay.
You have my math track address. Is that what you have? I can't keep track of who has what.
I don't know, but I have your email, so it
Okay.
shouldn't be a problem.
How was your day? Good?
It was good. I got some of my marks back.
Yeah.
Yeah, they were all right.
They were all right?
Yeah, not bad. Yeah, bio was a 5, which I'm happy with.
Oh, good.
Yeah, I can bring that up to a 6. So, yeah.
Good for you. And what is it that you want to study in college, do you think? How are you gonna save the world? We're in trouble.
I think I'm going for international law or politics. I'm kind of doing a joint between those.
Uh-huh. And what do you want to do in politics? Do you really you want to?
I don't want to be a politician, but I want to work for an NGO of some sort.
And I don't know what that is.
Non-governmental organizations, so like Greenpeace or
Got
Doctors
it.
Without Borders.
This is Hayes and Harris, this book. So, teacher's notes. So,
and then all the way at the bottom of the teacher's notes is the homework.
Do plus or minus sign stuff for both first derivative and second. I'm not sure. Maybe you can tell me if this is part of the assignment.
I can actually tell you which page it's on. Hold on. It is the homework starts on the, gosh, it's a long one. The homework starts
5 or 4?
Yeah, I think. No, I don't think so. Wait, I'm very confused. Oh yeah, homework starts on page 6.
6.
Yeah.
So she did some stuff in class.
Yeah.
Oh, I see where it says homework. That would make sense, huh?
Right.
Okay. Okay. There we go. B and D are stationary points and C is a point of inflection. I am very excited about this. Complete the table by indicating whether each value is 0, positive, or negative. Okay, so this is the function f, right?
Yeah.
So we'll go through this first. So for f,
isn't that just y?
Yes. So it's negative, right?
Right.
Positive.
Then
positive,
positive, and positive.
0, right?
Oh, 0. Yeah.
Okay, so talk to me about the derivative, or say, I have no clue how to do this.
So the derivative, so the first derivative is just whether the line goes up or down, and the second one is whether the tangent increases or decreases, is what I understood.
I'm not sure about the second one. Maybe I'll talk about the second derivative.
Okay.
Because maybe you're saying it differently than I'm thinking. But
Okay.
yes, the first derivative is whether the function is increasing or decreasing, but very, very important is the first derivative gives you the slope of the tangent line to the curve.
Right.
Okay, so right along here, the curve is decreasing, right?
Yeah.
And this tangent line, I just randomly drew it where it's decreasing, it's tangent at that point. Well, the slope of this tangent line is negative.
Yeah.
That's corresponds to the function decreasing, because if the tangent line is slanted this way, right?
Yeah.
That's always negative until it becomes horizontal. Yes.
Yeah.
And that's
Okay.
where it's equal to
0.
0.
Mhm.
And then if you keep on going, oh, it's positive. The slope is now positive, right?
Right.
Which corresponds to the function increasing.
Right.
So that's an important understanding, that it's really the tangent line that's driving the bus. So at
Okay.
A, it's going to be negative, right?
Yeah.
B is going to be 0,
Mhm.
positive at
C.
C,
Mhm. And 0 and
0 at
negative.
D, and negative, right?
Okay.
Now the second derivative tells us whether it is the function is concave up. Do you
Mhm.
know what that looks like?
Yeah, like the first
Yep,
thing.
this
Yeah.
is concave up, this is concave down, and that's a little deceiving because this is also concave up. This
Mhm.
is also, it doesn't have to be the whole
Yeah.
thing, right?
Okay.
Although these ones are. So A, it's concave up, so the second derivative is positive. B, concave up. C, they tell us it's a point of inflection. So that's
Right.
where it changes from concave up to concave down, or vice versa.
So it's
And
0.
yes, that's where the second derivative is 0. D is concave down, E is concave down.
Okay.
Make sense?
Yes.
Awesome. Okay, so where'd you go? Number 2. Oh, did I forget the name of your friend?
Oh,
Who I
Partha.
mentioned his name, Partha, Partha,
Mhm. Yeah.
and he lost his mind.
He hasn't seen it yet. I think I'm gonna prompt him to watch it. Maybe if he'll watch the beginning of the video. So Partha, if you're watching this, go look at the last one. But
Oh my
people do
God.
watch. I have another friend and he watches every single one.
Do you have any female friends, or is it all boys?
It's all guys in my class.
Really?
Yeah.
Wow. And I'm sure that's annoying for you.
A little bit.
Like,
A little
like
bit.
I'm good. Leave me
It's
alone.
okay.
No, I
Yeah.
don't want to. I don't want to date you.
No, that's exactly how it goes.
You're not worthy. All right.
Right.
You don't. You're not up to lot standards. Ooh, all these people are listening now. Okay, so in order to find stationary points and points of inflections, we take derivatives. Yes. So
Yes.
f prime of x is equal to 2x minus 2. And then we set
Mhm.
them equal to 0. Yes.
Okay.
And the reason we set them equal to 0 is that if there's going to be a stationary point, I hate the word stationary point, by the way, but it's going to be where the slope of the tangent changes from negative to positive or from positive to negative, because as you see, we'll have a min or a max. And
Right.
it can only happen if the slope is first equal to 0.
Okay.
Make sense?
Yes.
Or the tangent line is horizontal. They do all these things to you. So we find out, all right, where is this guy equal to 0? And are you okay that that's x equal to 1?
Yeah.
Okay, so we do our sign diagram for the first derivative.
What?
Does this look familiar?
No.
It's going to be, you're going to love it.
Okay.
So all we're doing is find the sign, S-I-G-N, not the trig, positive or negative, on these intervals. Okay. The sign of the derivative. Okay. So this is 1. So I choose any number to the left of 1. Let's say 0, because that's very simple to plug in. Well, if I plug in 0 up here, I get -2. I actually don't care about the 2. I just care if the result is positive or if it is negative. And it's negative.
What? Okay, so we've because x is 1, you go anything below 1,
Yes.
which is 0. You plug
Choose.
that in,
Mm-hmm.
then you get which one do I plug it into?
Into the derivative, because this is the first. We're
Okay.
checking out the first derivative, right?
Then it's -2, which is negative, and so then that means that this side of the curve is negative, like the
Is decreasing.
okay.
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 And then so we choose anything to the right of 1. How about 2? That's going to be positive.
Right.
Okay. So now we know that this stationary point is a minimum.
Okay.
Because decreasing and then increasing, right?
Right.
Okay, and we know this to be true because it's x squared minus 2x plus 3, and I'm just going to show it to you graphically. Okay.
Okay.
Y equals, actually, let's do this. Okay, so y squared minus 2x plus 3. Okay. So here's the graph of the function.
Okay.
And it's a parabola, so we know it's a minimum, right?
Yeah.
So the first stationary point is, and that's the only one, there's no other zeros, right? Okay, so that means we have a minimum, a min at 1, right?
Yeah.
And how are we going to find the y coordinate?
You plug it into the original equation?
Yes, which is 1 minus is 2, right?
Yeah.
And if you look at our graph, oh, holy smokes, that's 1, 2, isn't it?
Yeah. And we
And
found that. So we found out whether it was positive or negative, and using that, we knew it was the minimum.
yep.
And then because we found x, we could find y. That simple? Okay.
That's it. And do you see how the negative corresponds to the decreasing?
Yeah.
And the positive corresponds to the increasing?
Yeah.
And that's because you see, again, the tangent line, m equals 0. M is negative. And when I say m, oops, I missed it, but you know what I'm talking about. I'm talking slope or gradient, right?
Yeah.
That's what I want you to have, all of it, like the whole picture, that how the sine diagram relates to the actual curve, the tangent, okay, it has to be 0, that whole thing.
Yeah.
Okay. All right, so now the second derivative, which helps us find where the derivative is concave up and where it's concave down. Now, clearly, this guy is always concave up, isn't he?
Yeah.
All right, so, well, let's see if that makes sense. The second derivative of x is the derivative of 2x minus 2, which is 2, right?
Yeah.
There are no zeros. And f prime of x equal to 2, that's always positive, right? So it's always concave up. There's no critical points or stationary points. Always
Because
positive.
the second derivative is positive?
Yeah, because it's
Okay.
a positive 2, isn't it?
Okay.
Yep. Yep. Okay. Where'd you go? There you went. Oh, so now we have to do B, right? And C
Yeah.
and D. All right, so now we're getting a little more interesting. It is a cubic, so we should know, okay, it's going to be like that.
Yeah.
Because it's positive. If it was negative, it would be like that.
Yeah.
You see the difference? Okay. So just, okay, we know what we're getting into. Could flatten out somewhere, who knows? It's an adventure. That's why we love the calculus, am I right? So f prime of x, I didn't give you a chance to answer, equals 3x squared minus 12x plus 9. Yes?
Yes.
So we're going to set that equal to 0. We are going to factor out a 3, or you can think of it as dividing both sides by 3. And you end up with x squared minus 4x plus 3. Are you okay?
Yeah. So you can just do that. You can just divide the 0 whenever.
Yeah. 0 divided by 3 is
0.
0. It's totes legit.
Okay.
All right. So x minus 3, x minus 1. X equals 3. X equals 1. Booyah, right?
Booyah.
We're going to do derivative test. Oh my God. All right. So what you want to do, Lot? What do you want to test?
Do we do 0, 2, and 4?
Sounds great. You can do whatever you want, right?
Yeah.
And as long as it's on the interval, right? So now here's the first derivative, right?
It just becomes 9, no?
Yes, but as we plug in other numbers, you don't want to, I don't want to plug 4 into here,
No.
right?
Right.
It just is, well, as long as we're doing it correctly, this is a form of the second derivative. We factored out a 3, so there could be a 3 in front, but that's not going to affect the sign because that's positive, right? So plug it in where it's easiest, which would be here.
Yeah.
Not 0. 0 is easy, right?
Yeah.
It's just a 9, so that's positive. But 2, right? Well, you don't have to actually think of what the value is. 2 minus 3 is negative. 2 minus 1 is positive. Positive times a negative, negative. Choose 4. Positive, positive, positive. Done.
Okay.
Right?
Yeah.
Boom. Boom. So we have a, we'll write them up here so we have room to work. So we have a local max at 1 what?
I can't remember what the number was.
I'm just going to plug it in there to get y.
Oh, yeah, I was plugging it into the wrong place.
Oh my God, not that one. Holy smokes. This one.
Oh, right. This is a hassle. Yeah, 5.
You agree?
I agree.
Okay, so and then we have a local min. I know it's local because it's a cubic. At okay, so what a pain. 27 minus 54. I'm just plugging in 3, right? Plus 27. Ooh, that's good because these are gone. So it's just 1, right? 27 times, yeah. So it's at 3.
What?
I plugged in 3 here, right?
Yeah.
27.
Yeah.
6 times 9 is 54. 3 times 9 is 27.
Yeah, that makes sense.
All right.
Yeah.
Cool. So now we're going to take the second derivative. And that is equal to 6x minus 12. Right?
Yeah.
So we set that equal to 0 to get our concavity. X equals 2. Same thing. Second derivative test.
So 0 and 3.
Okay, so what happens with 0?
You plug it into the second derivative one.
Yep, but we just we set the second derivative equal to 0, right? We don't go outside the family on this.
So it's negative.
And
then the next one would be positive.
Positive. So we are concave down to concave up. So 2 has to be a point of inflection. Because the point of inflection occurs where the function changes from concave up to concave down or concave down to concave up.
But how do we know for sure it's exactly 2?
Because it occurs where the second derivative is equal to 0.
Okay. That makes sense.
Okay. So then point of inflection, I don't know if your teacher will allow poi, is at 2. And where are we going to plug 2 in to find the actual coordinate?
To the original one.
That's right. So that's going to be 8 minus 24 plus 18 plus 1. Yes?
Yeah.
It's 3, I think. I did it very quickly. 27 minus 24. Yep. There you go.
Okay.
And I'm going to show you what it looks like. I just really think it's important. That you see what you're doing, right?
Yeah.
You see the fruits of your labor, Lotte.
Yes. Such hard work.
Plus 9x. Plus 1. Boom. Right, so whoop. All right, so let's check her out, right? So local max at, wait a second.
Oops.
I put it in wrong. Minus 6x squared. Oh, there we go. Okay, so do you see how we have our local max at one five, right?
Yeah.
We have a local min at 3-1,
Yeah.
and you can't really see it very well, but at 2, 3,
Yeah.
I think we can reasonably say, all right, concave down to concave up.
Yeah. Okay.
Awesome. All right, so C. All right, give me the first derivative.
3x squared plus 12x plus 12.
Tell me what to do.
Equal it to 0, and then take out the 3, and then factor it, which I'm really bad at.
I'll do this for you.
Oh, is it 2 and 2?
Yep. She's busy.
Yeah, it's my dad. He's talking
Oh,
about
you're not busy, too busy for dad ever.
No, no. All right, and then now you plug in the, so like -3 into, can I just do it into the first derivative, but then do the x plus 2 and then x plus 2?
Yeah,
So,
that's what I would do.
-3 plus 2 is -1, and -1 times -1 is 1. So it's positive. And then 0, 2 times 2 is 4, which is positive as well.
That's weird, isn't it?
Yeah.
Right. So it is, I forget what Hayes calls these. Because different folks call them different things. I'm going to open up Hayes real quick, if you don't mind.
Yep.
Boom. Technology is ridiculous. I mean, come on. I got right to the page in under 15 seconds. Okay, so this is called a stationary inflection, is what they call it, because, and you'll see when we look at the graph what this looks like.
Okay.
Okay, but we'll say stationary inflection, because that's what Hayes calls it, right? Stationary inflection. And that is at -2. Oh, for crying out loud. So -8. 24. -24, yay. 5, so it's -3. Yes?
Yes.
Okay, so now the second derivative is equal to 6x plus 12. Wow, this is interesting, isn't it? Which makes sense when you see it. That equals 0, x equals -2, right?
Yeah.
Okay, now we're going to get a bit of a different result this time. So if I go -3, that is negative, yes?
Yeah.
-1, positive, or 0, positive, right?
So that means the point of inflection is at x equals -2.
Yep,
Yes.
and we
Okay.
don't have to plug back in, right?
Mhm.
And that's at -2, -3. So what is that all about? Do you have an idea of what this graph might look like?
Like a U shape of some sort. I'm not sure.
Okay, so it's one of these cubics that flattens out,
Okay.
right?
Yeah.
So that's why, because the curve is continuously increasing. It takes a little break. It is the tangent is 0 there, but it does keep on increasing for the first derivative.
Okay. Oh yeah, so it
Okay.
never goes down. Okay. Yeah.
Correct. And we're staying true with the second derivative, because from -∞ to -2, it is concave down. Do you see that? Like, ooh, it's really concave down to here, right? And then it's concave up. And you can see where it changes at -2, -3.
Okay.
Good?
Makes sense. Yeah.
Right. So that's what that's all about. All right, so D, you want to give me the derivative?
-12x to the third minus 24x squared. That's it.
Good. So a classic quartic looks something like that.
Yeah.
Or like that if it's flipped, like this one is. All right, what do we have in common? What can we factor out?
12.
How about a -12? Makes our life a little easier.
Times x cubed. So in brackets, no? Or
well, we can factor out an x squared. And we're left with x minus 24, right? Not minus 24. Why did you say 24? I don't know why you did that, Lotte.
I don't know.
-2. Stop that. You're messing me up. So x equals 0 from this first factor, and x equals 2.
Okay. -1, 1, and 3. So if I do, see, but now it's not the easiest to do it in the last one, right?
Oh, it's very simple, because anything squared is positive, isn't it? Except for 0, then, right? So if it's positive, no matter what I plug in here, it's going to be negative.
Yeah.
Right? So I now know this is negative, no matter what.
Okay.
So I only have to plug in here, right?
Yeah. Which
So
would be negative.
Right? And so a negative times a negative is a
Positive.
positive, right?
Okay. And then the same thing, positive.
Excellent.
And negative.
Good. So we have for D, we have a stationary point of inflection. I don't know what your teacher is going to call them. That's why I'm changing, but it's stationary at 0, 2.
Yeah.
And then we have a regular point of inflection, right? Because we're increasing, and then we're decreasing, right?
Yeah. At
Here,
2,
so good.
2 something.
So -3 times 2 to the 4th, 2 to the 4th is 16, -3, so that's -48. -8 times 8, so that's -64. Plus 2, that doesn't give me much help, does it? 60, -100? No, -110, I don't know.
Hold on, I
-110,
have my calculator out.
112, yeah, -110.
Yeah.
Okay, so let's do the second derivative. This is definitely going to be worth a look, isn't it?
Yeah. Wait, and that's the only stationary point? Is that?
Because
Okay.
it's only, these are my only zeros, right? For my first derivative.
Right. And the other one isn't a stationary one?
Which one?
Are they both stationary?
They're stationary, but this is a stationary point of inflection, meaning there's no change in increasing or decreasing. In this case, they're just decreasing. This is a point of inflection.
And in what case would it just be a stationary point?
They're all stationary points. It's
because it changes? Is that why?
well, it's either a stationary inflection point, right? Stationary inflection.
Mm-hmm.
I shouldn't have said POI. Stationary inflection point.
Yeah.
Or I want to make sure. Oh, I'm sorry. We should call this. That's not a point of inflection. I'm sorry. This is, I was going second derivative on you. Thank you for questioning me. This is a local max, right?
Okay. Yeah.
Up and down. So this is an L max. Is that okay?
Yeah. And that's also a stationary point.
Yes.
Okay.
But we have a better name, right, for it?
Right.
Okay. And then second derivative, right?
Yeah.
Is going to be what?
Hold on. 36, so -36x cubed squared, sorry.
Mm-hmm.
Minus 48x.
Good. -12x, sorry, times 3x minus 4,
Yeah.
36, 48. Yep. So that means that x equals 0, x equals 4/3. Yeah.
Yeah.
0, 4/3. F double prime. Plug in a negative. Negative times a negative is a positive. This is going to be negative.
-3 minus, so it's negative as well. So it's, yeah. Okay.
Negative, right?
And then
Negative,
1.
negative.
Yeah.
2. Negative,
Positive.
positive is negative, right?
Yeah.
Concave down, concave up, concave down. So we have 2 points of inflection, right?
Mhm.
So we have a point of inflection at, oh, thank God, at 0, 0, 2.
Yeah.
And oh, isn't this great? Point of inflection
At 4/3
at
something.
4/3. It's a race. Are you doing it or waiting on me?
I'm trying to do it.
Oh, it's not cubed. I almost messed that up. Okay. Negative 26 and 4/9. Woo.
Wow. I can check if that's right, actually. I have the answers.
Yep. Let me give myself some more room there.
Yeah, that's right. Is it did you get 310 over 27?
I don't know. No, I got my calculator was set for decimal. So what is it? 4/3. Negative 26.4 repeat. I'm going to put, okay.
Yeah.
Do you want to see the graph? Or are you okay? Do you
I think I
you
know
got
what it
it?
looks like. But
Okay.
so in that case, can I, because once I found the points on, like the points of inflection, do I really need to say whether it's negative or positive?
Say if what's negative or positive.
So let's say I found x equals 0 and x equals 4/3. Do I need that step after that?
Oh yeah, because if they are the same, you don't know.
Oh, then it's not a point
It's
of
right,
inflection.
right.
Okay.
It's a stationary inflection point. Right. Yes, you totally
Okay.
need this. Okay.
Okay.
All right.
So a stationary inflection point is where it's plus plus and whatever's in
Or
between.
minus minus.
Okay. And then
Yeah.
just an inflection point is when it's plus minus minus plus.
Correct.
Okay.
And then max or min, right?
Yeah.
Right.
Because it, yeah. Okay.
Okay. Let's do this. I don't think we're going to get through all the homework lot.
That's okay.
Ooh. So they want us to, I guess, sketch another graph, not on top of this, right?
Yeah.
Okay, so here we go. This is why it's really sort of important to understand our tangent line thing here,
Okay.
right? So we're sketching the graph of y equals f prime of x.
Okay.
And we really don't have any values, it doesn't matter. But do you
Okay.
see that the tangent line is equal to 0 here?
Yeah.
Okay, so that means the derivative at this point is equal to 0.
Yeah.
Right? So if I go straight down, that's why I did it the exact same size. Right here, I know I'd have a 0. The derivative is equal to 0.
Yes. Because
And
x equals 0 or y equals 0?
yeah, so the value of a function is always the y coordinate, right?
Mm-hmm. Okay.
Okay. And all the y coordinates are 0 on the x-axis. Same thing here, right?
Right.
So right here, I have a 0 as well. Yes.
Yeah.
Now right here, the derivative is positive or negative?
Positive.
It is positive, meaning it is above the x-axis.
Mm-hmm.
Right here, the derivative is
Negative.
negative, and then it is
Positive again.
positive, right?
Yeah.
Okay. So you have to be, it's really weird, right? It's really weird because this is what it's going to look something like this. It's going, number one, it's going to be a parabola. I'll tell you why in just a second. But it's going down here, isn't it?
Yeah.
But the value is still positive.
Yeah.
And that's what we need, right? It has to be above the x-axis. And between here and here, it has to be below the x-axis because the derivative is negative. And then here, it has to be above the x-axis because the derivative is positive.
I thought the derivative was just whether the line goes up or down.
Based on the slope of the tangent to the curve, right? So let's call this, I don't know. Let's call this A. F prime of A equals 0, right?
Yeah.
So if I had an ordered pair here, right? I would have x and y equals f prime of x, yes?
Yeah.
So at A, it's 0.
Yeah.
At B, B, it is 0, right?
Yeah.
Okay, and let's just, I don't know, let's just say right here, let's call this C. And I'll go red now. Let's call this C,
Yeah.
right? And the value at C is the slope of that curve, isn't it?
Yeah.
C, well, f prime of C, I don't know. No, I'm sorry, it's positive. It's positive. It's it looks like it's about, let's just say that the slope is, it's pretty steep. Let's say the slope is positive 3.
Yeah.
Estimate, right?
Yeah.
So we're going to say f prime of C is equal to 3. You okay?
Yeah. Yeah.
Okay, well, now let's do E, like right here. Let's say that's E, right?
Yeah.
And let's just say that the slope is -3. It's about the same, right?
Mm-hmm.
So at E, f prime of E is -3.
Yeah.
And then at F, we'll say it's 3 again. We'll call this F. Actually, we won't. We'll call it E, F, G, H, I, J. We'll call it K. And we'll say F prime of K is 3.
3.
So right
Okay.
here, right? This is
Yeah.
F. M equals 3. Those are all estimates. Remember that. Okay.
Yeah.
So if we plot those points, right? If I come down here and what? This is C. Well, C is 3, isn't it?
Yeah.
Right?
Yeah.
E. Why did I skip D? Why did you skip D? A lot. I don't know. D is -3.
Yeah.
Right? And then E is 3.
3.
So do you see?
Yeah. So you're plotting the points, the derivative points, basically.
The value of the derivative. It's
Okay.
hard to get your head around,
Okay. That makes sense.
right? Now, the other thing is this is clearly a cubic, isn't it?
Yes.
So
Oh, and
it's
it becomes
something.
squared.
So it's a
Parabola.
parabola.
Mm.
Make sense?
Yes.
All right. Aha. You want to try that? I have to go to the restroom real quick. Sorry.
Okay.
Okay, I'll be right back. How'd you do you think?
I drew the first graph and then I thought about it, and that's it. I couldn't do it.
Okay, so they gave us the derivative, yes?
Yes.
Okay. So let's think about this. With a derivative, we can do a sign diagram. Isn't that exciting? I sound really
No, that
excited because
is.
I think it's so cool. Okay, we're going to do a sign diagram. I could draw a straight line. So this is F prime, right?
Right.
This is F prime, isn't it?
Yes.
Now, we set the derivative, the first derivative equal to 0 and find out where it is 0, don't we?
Yeah.
Okay, well, isn't it equal to 0 at -3 and 1?
Yeah.
-3. and 1. Yes?
Yeah.
Okay, and to the left of -3 is the derivative positive, or is it negative?
Positive.
So happy you said that. What about between -3 and 1? Is it positive or negative?
There's a bit of both.
Mm-mm.
Oh,
From
positive.
here to here, it's all below the x-axis. All of these values are negative.
But I thought that was just yeah, negative. Oh, because that's the derivative being graphed. It's not what the
derivative.
actual graph looks like. Okay.
Yeah.
Yes.
And here it is
Negative as well.
negative. So we have a local max at -3, right?
Yeah.
And we don't know where it is. We don't have enough information on this
Okay.
because we don't have a scale, right?
Yeah.
So I'm going to decide to put it here, right?
Okay.
Okay, and then something else is happening at 1. We'll get crazy and we'll put it down here.
Okay.
Okay, but to the left of -3, my graph is increasing. And then it's decreasing, decreasing, decreasing. Negative, negative, remember, it takes a break and then continues to be negative.
Okay.
And this graph could slide up or down. We don't know where it is.
Yeah.
So it really
Okay.
doesn't matter where you put it.
Yeah.
How you feeling? Overwhelmed?
Yeah.
It's a
It
lot.
makes sense, but it's just because the derivative graph confuses me because I keep trying to look at it like a normal graph.
Yes, you have to
Yeah.
keep saying to yourself, the value of the derivative, the value, the value, the value, the value.
Yeah.
Not
Yeah.
the shape, right?
Yeah.
That doesn't matter. Above the
Yeah.
x-axis, below the x-axis. On the x,
Right.
that's all we care about
Right.
for the derivative.
So if the derivative is negative, then we know that the slope is also negative. Yeah.
Yes.
That makes sense. Okay.
The sign diagram, right? Once you make your sign diagram, forget about the graph, right?
Yeah. Okay. Makes sense.
All right. See you in 2 days.
Yeah. See you in
All
2
right.
days.
Well, listen, stay out of prison over there, okay?
Yeah, I do my
All right.
best.
Okay.
Okay. Bye.
Bye, Partha. Bye, Partha.
Bye.
Bye.